Always a winner. Always a winner. Good evening, all. People are still coming in, so we'll give it a minute. I hope you've all had a good week.
Hope you've all seen the comet, more importantly.
Broke up for a second, unless I did.
Fozzie Bear. Oh, these noms de guerre appearing here. Spiky.
That's his real name.
Yeah. Jolly good. Jolly good. A couple still coming through. Oh dear.
Just seeing how many people have got glasses of wine on the go.
We've got a resident guitar player, haven't we? Somebody's normally playing the guitar.
Yeah, there he is, Dave Harvey. Evening, Dave.
My Fender Strat was on this chair behind me a minute ago.
Was it? Okay.
Yeah, yeah.
Is there a musical interlude halfway through?
Well, it could do, yeah. I only played rock and blues, though.
That'll do. That'll do.
Yeah. So
I think that's probably everyone in now.
That'll probably do us to get going. Okay, so good evening, everyone. Again, I hope you've all had a good week. I don't know if you heard Grant say, I hope people have been looking at the comet. I have to say, I have not as yet. Hoping to, or maybe tonight I'll get a chance to get out there. Plenty of pictures doing the rounds around social media and the internet. And if we ask David nicely, he might tell us about his picture of the comet that he took earlier. So we are delighted to be joined by David Bryant tonight. I'm sure many people have seen David speak before, or indeed met him at many of the star parties and other events that David attends. Of course, with his meteorites, with his space rocks business, and that is the subject of tonight's talk. David, as you probably know, is involved in many things. He's been a teacher several times. He keeps retiring, and they keep dragging him back, and he keeps retiring again. Ex-naval officer, lecturer, rock guitarist, as you just heard, published artist, and of course a published author as well. And I think, David, you are the UK's only full-time meteorite collector. I think we're right.
yeah, I am now. There used to be another guy in Scotland, Rob, but he retired. And one or two people tried to take it on, you know, but it's, for a start, you need a lot of specific knowledge, and even more, we'll talk about later, you need a lot of contacts without the material, you know.
Yeah, absolutely.
And I wouldn't want to be reliant on it as a main income. Let's put it that way. Okay. It's a very nice second income for us. Yeah.
Okay. Well, before we get into that in too much detail, then, so tonight is more a sort of conversation type affair. We're going to ask David some questions. We're going to kick him off, but please, if you've got some questions, flag it up, and you can ask your question to David, and David will take us through what should be quite an interesting 20-year gold rush around meteorites. So, David, to kick us off, how did you get interested and started out in meteorites and collections?
I came into meteorites the way a lot of people do, through geology. When I was about 5 or 6 years old, we had a family holiday down in Dorset, and inevitably we went to Lyme Regis, and equally inevitably I found some ammonites and belemnites, and I was hooked. And the year after, we happened to be on a holiday in Ilfracombe, and in a junk shop I saw this. Okay. And it's a tektite. I'll mention what they are later on. But I saw the magic label next to it, saying it's from space, and I spent my entire, as kids will do, holiday pocket money on this one item, and that set me off. And I got interested in it. And you have to know I'm quite old, right? I'm nearly 70. golden era, which meant I was at just the right age. I was 6 when satellite was Sputnik 1 was launched. It was also the same year we had 2 brilliant comets, Marcos and Aaron Rowland, which I saw, precocious little brat that I was. And 61, Gagarin and Shepard. So having an older brother, he and I, Sam, we just got involved in astronomy. We were allowed to stay up late and watch Patrick Moore, Sky at Night.
Yeah,
a treat every month. And I don't know about you guys, but that music, Peleus and Melisande, the theme music, it still puts the hair up on the back of my neck.
Yeah, absolutely.
And so that I need to sort of, if there is a title or a theme for this talk or this discussion, this chat or whatever it is, it would be, the 20-year gold rush, I've called it, meteorites. Because if you went back to the 60s and 70s, meteorites were very, very hard to get. I mean, they just were not available. There wasn't that many people out there looking for them. Those that were found tended to immediately be whisked away into collections. You might remember the Barwell meteorite in the sort of late 60s. Patrick Moore got deeply involved with that. And it was just before Christmas, I think it was, Boxing Day. This meteorite exploded over Barwell in Leicestershire. And I was about 15 or 16 at the time. I remember trying really hard to get hold of some of that. Just wasn't possible. And that's kind of how it stayed until the advent of the internet. Now, Space Rocks, that's my website where I sell my meteorites from. Space Rocks UK has been online since 1998. Wow. In the wonderful days of dial-up and, which we all remember. And sort of serves like CompuServe and FreeServe and stuff. You had to change your host about every 5 minutes because it kept going bust.
I was going to say, you are in Norfolk, so it's probably not much better now.
Cheeky devil. At least we have clear, dark skies. Yeah. And I mean, you used to have impossibly long URLs, didn't you, as well?
Yeah.
But I don't know if any of you guys would remember this. I can't remember which of the hosts it was, but suddenly this website appeared called Bidville. Any of you remember Bidville? Bidville was the basis, I suppose the originator or progenitor of eBay. And it was about 1999 or 1998 first. And I just, I was glancing through it when it first appeared. I heard about it. At the time, I was teaching IT at school. And it was part of my thing to check what websites and what search engines and so on and so forth were suitable for kids, because there was very little policing of the internet in those days. I was going through this bit, and suddenly there it was, a meteorite for sale. I thought, blimey, And of course, what immediately goes through your head is that can't be genuine, So, but I kept on watching it, and as time went by, more and more and more of these meteorites were appearing. Now, I should say, I'd already started a space business. Some of you might know, I used to sell space-flown hardware, and I had a very good relationship with lots of astronauts. I used to get them to sign. They're very vain, like all of us authors. We authors. If you bought a box of books, they'd sign them. Now, you take Buzz Aldrin, for example. He brought out a kid's book, and he'd sign those for free if you bought a box of them. At the time, his autograph was selling for about £250. So this is obviously the basis for good business, wasn't it? So I got into doing that, and through the astronauts and other contacts in America, I started buying and selling space-flown hardware, bits of, Saturn rockets and, Mercury Atlas and so on and so forth. And because I already had the presence online, and I was already attending collector shows and events like Autographica and so on, I thought, well, let's see if I can get some of these meteorites. And to cut a long story short, I knew a guy in Cambridge, I shan't give him a plug because he wouldn't give me one, who is an importer, wholesale importer of mineral specimens and fossils, particularly from Morocco. And I got in touch with him, in fact, I went and saw him and said, can you get me these meteorites? Well, this was the start of this kind of gold rush that we're talking. What happened was I don't know if you know, there's an area called Kem Hills in Morocco, which is just about the best place on the planet for dinosaur fossils. Those of you who've seen Jurassic Park, or Cretaceous Park as it should be called, you know there's a monster there called Spinosaurus,
Yes.
the one that fights the Tyrannosaurs in every film. There are huge beds of Spinosaurus fossils in Kem, you know, and he occasionally would go there. And, you know, he had an office in Marrakesh, but he'd go to the Kem area, and he had a network of Berbers and Tuaregs who would go out collecting for him. And he just said, "There's a guy I know, lunatic in England, who will buy any black rocks you find." Because at the time, they didn't have any sort of level of collecting expertise. So what they started to do, I would get a large box or a small crate of material from Morocco that these Berbers, desert Arabs, had collected. And there'd be seashells, there'd be fossils, there'd be camel dung, honestly, and in among them would be meteorites. I should say my degree is, to a large chunk of it, is meteoritics and planetary astronomy. So I knew what to look for in a meteorite. And quite quickly, I was buying quite a lot of these things in, and you'd go through them, and you'd find not just the usual, a normal stone meteorite that you might, pick up in the Sahara. I was getting boxes full of these. They weren't that size. The great majority were kind of rubble like this.
Okay, yeah.
And the discriminatory is the density. They're very dense compared to terrestrial rocks. They're magnetic, attracted to a magnet, so on and so forth. They have fusion crust and all that. And it goes up from there, and the word soon spread. I started selling these at my space memorabilia events. I think initially my interest was just to get things for myself. And then, you'd get a guy in France would say, "I've heard you've got some nice chondrites, and you've got some iron meteorites from North Africa. I've got some stuff from South America," or another guy would say, "I've got some Australian stuff." Or a guy in Namibia would say, "I've got some bits and pieces of Gibeon," and so on and so forth. And well, of course, once everybody realised where all these meteorites were coming from, it really did. When I first started doing this, these Berbers, I hope this is interesting, these Berbers, what they would do, they would literally, there'd be, I suppose the odd one might have an old 4x4, but the great majority were on donkeys or camels, animal transport. And a lot of them were living in because it's a very, even then, it was an area with a lot of problems, war between Mali and Morocco and Western Sahara and Mauritania. They're always fighting each other on the borders. And there was a huge refugee camp at a place called Tindouf. It's called the Rissani camp. And a lot of them, what they were doing, they were drifting off from this camp and wandering about thinking, well, we can get dollars, for these lumps of black rock. And soon it became a real cottage industry. To cut a long story short, of course, they got to be quite good at finding them, because I'd give them feedback, and American dealers and German dealers, anybody else, and people were importing, between us, we were importing tons and tons and tons a month. Gosh. And I remember having a discussion with Monica Grady once, Dr. Grady or Professor Grady, and she really didn't think this was a good idea, because she said, these things are, you're stripping the desert. And of course, two things. Firstly, I said to her, well, not really. I mean, where they land, the Berbers don't tell you where they find them, because what they don't want is people to go there and look for them themselves, So to cut a long story short, there was this kind of a bit of a dialogue between academics and meteorite dealers, and it got quite hostile at the time. But it seemed like these things would never, the supply was unlimited, and people were finding bigger ones. And then, of course, if we sort of, in 1981, which is before this story started, but in 1981, the first definite guaranteed lunar meteorite was discovered in Antarctica. And so the characteristics of lunar meteorites and then Martian meteorites was understood. And if you wanted to know later how we, in general terms, how we know where they're from, but people started finding not just lumps of common chondrites like these. This is the majority of what was found. By now, the Berbers, of course, were driving around in brand new Toyota Land Cruisers, and some, honestly, you wouldn't believe it. They have the rear bumper hanging suspended from that and have a long electromagnet, and they just put this thing on cruise, get a book out, and just go in a straight line. I should say, people's images of that part of the Sahara, the foothills of the Atlas and stuff, is sand dunes with Lawrence Arabia, in his burnous. It isn't like that at all. It's flat limestone plateaus for the most part. So these black rocks stick out like a sore thumb. They just drive along for a kilometre or two and stop, remove the meteorites from the electromagnet, turn around, go back and forth. And needless to say, I mean, this for 20 years, people were getting better and better and better results. And of course, the birth from Tanzania, Algeria, Tunisia, Libya, everywhere, the whole of North Africa. But the thing about meteorites, probably 300 tons, minimum 300 tons a day lands on Earth. Some people have put the figure as high as 12,000 tons. Because most of it falls in the sea, most of it's micro meteorites, dust and stuff. But there's plenty of it out there. And so they had no problem finding the material. You wouldn't find, if one landed overnight in your garden, I bet you wouldn't notice it, particularly if it landed on your driveway among all the gravel. The Berbers were finding these things simply because you've got this lovely white pavement of limestone. And you can see these black meteorites. You can imagine against the white background, that would stand out, Yeah. If we were doing a PowerPoint, I'd show you some photographs they used to send me where they found them. Anyway, to cut long story short, for 20 years, from we'll say about the year 1998 or so on till about 2018, or perhaps, really and truly, millions and millions and millions of pounds or dollars. They're always dealing in dollars. I will say this. I hope this is interesting. Say shut up. Because you realise in Islam, people are not allowed to involve with. They're not allowed to be involved with things like credit cards and stuff like that. They're not allowed. It's to do with usury, money lending, and speculation. The religion is quite strict on that. So it's quite hard to pay the guys, but once a mechanism was established for paying people in Islamic states, then suddenly across the whole of North Africa and down into the Arabian Gulf states, things would just turn. And little surprises like Oman is an area with pockets of lunar meteorites for some reason. Nobody really knows why, but there's a concentration of them there, like there is on Antarctica. So as the Berbers got better and better, a lot of them went to university in Paris. There was a guy there called Albert Jambon, professor. He would take these guys under his wing and educate them for 20 years. And amazingly, they were turning up incredible irons, pallasites, all the different types of meteorite were being. And just when people thought there couldn't possibly be an end to it, there was. Two things happened. One, the guys suddenly realised they'd been selling it too cheaply, and that this stuff was by no means as common or abundant over the whole planet as it appeared to be in the first place. And secondly, they really had overexploited it. A lot of the major falls, once they were discovered, there was a very famous discovery. I think it's Algeria. Meteorites are named after the place where they fall, or they're named, given a catalogue number. So you might have like, for example, we said the one that fell in Leicestershire is called Barwell, after the village where it landed. A lot of the ones from North Africa are called NWA something, which stands for Northwest Africa. Here's a Martian meteorite. That's funny. Look, the camera reverses it. You have to stand on your head. That says NWA 122. That's in Northwest Africa, and it's the 12,269th meteorite to have been discovered at that time, which I think was about 2 years ago. I mean, I actually had pieces of MWA 3 and 4. You know,
Gosh.
So you get the idea that 20 years it became a real major source of dollar income. And then another thing, other countries had started doing this. Australia, I think, was the first, followed by other countries, saying, well, hello, this is our heritage. This is our scientific heritage, which has just been exported wholesale as a kind of commodity. It's not even being used for scientific purposes or research. And in fact, the option to use these things for research is being precluded, because they're going straight to people's cabinets. Even worse, they're being used, we do this, Linda and I do this, they've been used to make jewellery and necklaces and God knows what, And so this dichotomy got even more apparent at the time. So many countries, one after the other, began to ban the export or even the collection. You can't export meteorites from Australia without a license. Canada is a bit iffy about it. South African states. The only one that hasn't done so far, perhaps not surprisingly, is Morocco. And you probably work out why. Because, and it explains another strange thing, what the Berbers were, because the Moroccan government was getting a nice bit of money in taxation and stuff and so on and so forth, and tourism as well, and in foreign investments. But what the Berbers were doing was very clever. They'd sneak off into Mauritania or Mali, or Chad, or even Libya and stuff. They'd collect the meteorites there, and they'd sneak back over the border with them and say they'd found them in Morocco. So my answer to Monica, Dr. Professor Grady at the time was, the thing is, we have no idea where these meteorites actually come from because the Berbers don't tell you. Like I said, that NWA 869 is a huge strewn field, huge, vast, covers an area the size of the Isle of Wight. But nobody knows where it is. They've got a rough idea. That's but because of course it's a regular sort. Every time they need a few extra quid or dollars, they go and pick a few more up.
So
that's
my question on that.
Yeah.
Sorry. So with that classification number, could you have different classification numbers that actually relate to the original source meteorite, or are they always, NWA1 will always be different fragments of it? They can relate back no matter where they're found. Oh well, NWA refers only to meteorites from Northwest Africa. Okay, and they started off with NWA 001, 002, 003, and so on. And once that's assigned, that's permanent, and it refers just to that meteorite. But is it possible to look at the chemical composition then and know? Yeah. Yeah. Okay. As I was going to say, the thing is, there are something like there's over 300 lunar meteorites known, or they've been assigned different numbers. But as you say, chemical analysis reveals that some of them are actually one of those paired or twinned meteorites. So the Berbers, what they've done, they pretended they found 3 or 4 different lunar meteorites, because you get more for a new find. That's another quick definition. If you actually saw a meteorite come screeching down a land, as happened in Barwell, as happened in Lachlan Bridge and so on, that's called a fall. If you just chance upon one, that's called a find. Now in Britain, there's over 100 falls known to astronomy, but only 3 finds. That's how difficult it will be to. And one guy, that guy I told you about in Scotland, Rob, he's the guy who found all 3 of them. Wow. So in other words, unless you actually, quite a lot of meteorites are probably paired. But I mean, Endo 869, it's a huge strewn field, and if we got, can I move on just to say how meteorites are classified?
Yeah, please do. Yeah.
Because that's part of this story. So the original meteorites, these things, common chondrites, as most of you will know, are the basic first solid matter in the solar system. Okay. Yeah.
Good question, Steve. I'll answer that in a second. They're made up of chondrules, which is widely assumed, although there's some new research which suggests another possible origin for them. But it's widely assumed that chondrules condensed from the solar nebula at the start of the solar system about 4.5 billion years ago. And they accreted, these chondrules, bigger and bigger, form bigger and bigger masses till finally get lumps that are so big that they actually planetary sized. I mean, there were a lot more planets in those days, the planetesimals in the solar system, and they were colliding together to form, like the moon and Earth. When you get big enough, the heavy elements sink through to the center to form a core. There's a process called differentiation. Okay, so if you've got a really ancient meteorite, it's undifferentiated. You can see the chondrules inside it. It's very dense because it's got lots of nickel iron. Of course, if you've got a meteorite that's come from a planetary body, which some of them do, then the nickel iron and all the other heavy elements are sunk through to the center. So the oldest meteorites then are chondrites, lumps of the original material that's solidified in the solar nebula. If you get imagine this kind of game of solar billiards that was going on in those days, with planetesimals smashing into each other, they would be disrupted, and quite often that would release their core. So here's a huge lump of nickel iron. It's a very famous meteorite that's actually called Sikhote-Alin. This is the most expensive meteorite I've got on my inventory at the moment, because it used to be quite cheap and now it's not. It's a nickel iron, and of course it comes from a famous fall. It's called, the others are NWA because they're from Northwest Africa. This is called Sikhote-Alin because it exploded over the Russian naval base in Vladivostok, and the material scattered down in the Sikhote-Alin hills in Siberia. So these iron meteorites are the core of a disrupted planetesimal. Okay, some of you might know there are even asteroids that all they are is the core of a planet. It's just a solid lump of nickel iron. I think NASA is going to explore one in a couple of years' time and land on one. I think it's called Psyche. They're called M-type asteroids anyway. So you've got nickel iron ones. So you've got the core, and around the core you have material like this. This is a palisite, and palisites consist of a nickel iron matrix, and suspended in it are crystals of olivine. And it's, again, nothing's set in stone, but it's generally assumed that what you have here is a planet that's been disrupted. Its core has been released, and around the core would have been a contact zone between the core and the mantle, the rocky outer layers of the planet. So this is the core mantle boundary material of a disrupted planet. And they're called palisites. Somebody asked a question about how we know. I'll just say how we know that a lump of iron is a meteorite. If you cut a meteorite and etch it, if you can see that, you get a characteristic pattern. It looks a bit like the pattern you get on a galvanized bucket. It's called a Wittgenstein pattern. And iron meteorites are classified according to the size and structure of the Wittgenstein pattern. I want to get too technical, but then iron meteorites are made up of two nickel iron minerals, teenite and camosite. And when you etch it, what you're really doing is you're making use of the fact they have slightly different solubilities. You etch it in iron chloride or strong acid, and one of them dissolves quicker than the other. So you only get this pattern, this Wittgenstein pattern, in an authentic meteorite. You wouldn't get it in a terrestrial iron or anything like that. So there's the first two of the types of first three types of meteorite. Ancient stony ones, common chondrites, that are the original material of the solar system that built the planets. Once the planets differentiate, you then get a nickel iron core. Around that, you'll have a thin layer of the core mantle boundary, which is called palisites. And then, of course, you've got the crust material and the surface material, and that's the third kind of meteorites, things called achondrites. And achondrites, the first group of achondrites to be really tied down to a planet are known as HED meteorites. And the H stands for howardite, that's a howardite. Okay. The E stands for eucrite, and that's a eucrite. And the D stands for diogenite. And what they are, a eucrite is basically the matrix of an asteroid, the regolith, the outside layer of an asteroid. If you've must have seen pictures of Ceres and other asteroids, you know they're covered with craters. The solar system, you know, there's been wave after wave of massive bombardments and collisions, and you know, asteroids colliding with each other. If you look at, for example, Ceres, it's got a huge crater on one of its poles. Those collisions are, you know, because asteroids have quite a low gravity. Material excavated by that, you know, from the surface material would be this stuff, eucrite. So eucrite is from the surface of a planetary body, and in fact, 90% of the ones we know are from Vesta, the asteroid 4 Vesta. Okay. If it's a big enough impact, it will actually excavate the crystalline material from, you know, mostly pyroxene from deep down inside, and they're called diogenites. And quite often they're nice colours, greens. Quite a few of them are greens and yellows and stuff, and very crystalline, translucent. So this is a diogenite, again from Vesta. And of course, in between, you'll also get regions which have been blasted again and again, and so you get diogenite material, eucrite material mixed together, and you get a very fine breccia, and that's called a howardite. So these were the first, if you like, planetary body meteorites that were identified, even before Lunars and Martians, and they're called HEDs. And they're called achondrites. A means none or without, and chondrite refers to that because they're from the surface of a planet, they can't possibly have chondrules. There's I hope I'm not gabbling, but there's a really, I don't mind Dan Brown and his books, okay? But he wrote a book, I think it's called Deception Point,
yeah,
where a meteorite is found, it's got fossil arthropods in it, right? And it's going to change our whole view of the cosmos. And you know, how did they know it was a meteorite? Because it had chondrules in it. Well, you know, as I'm sure you've already worked out, or if you didn't know already, to have life on its surface, a body would have to be big enough to have weather patterns, and it'd have to be a fully differentiated body. Chondrules would have disappeared, you know, very early on in that story. So it's actually impossible to get a meteorite with fossils in it. You see why, can't you? Yeah? You know, because this thing here, it's got chondrules in. Oh, not that. It's got chondrules in because it hasn't differentiated. It's still got the original structure, but once it's been heated up, metamorphosized, chemical, it gets the size of a small planet, you get chemical weathering and so on and so forth. The chondrules disappear, and all you're left with here's an undifferentiated meteorite slice, and you can see the chondrules in it probably.
Yeah. And
you can see the metal twinkling. Yeah. You know, get that. You couldn't possibly get that in the surface of an asteroid or anything else. So Dan Brown, I'm afraid, was way off being there. So you've got achondrites. Of course, the most exciting achondrites are the ones from Moon and the Mars. And the gentleman before asked, how do we know? Again, I don't want to get too technical about this, but you all know that most elements have several different atomic forms called isotopes. And they vary the number is, they have to have the same number of protons, electrons, that's the atomic number, but the number of neutrons can change, can alter. So as you know, hydrogen, for example, can have no neutrons, it can have one neutron, it can have two neutrons, okay? Well, oxygen has loads of different isotopes. And it's been discovered that it is possible to, if you do an estimate, to compare the amount of two of the isotopes of oxygen, O12 and O14, compare it with an Earth standard, it's discovered that certain classes have a characteristic O12, O14 relative isotope ratio. And of course, the rocks they brought back from the Moon, that's now exactly what it was on the Moon, and not surprisingly, it's the same as it is on the Earth.
But the estimates, assays that were done by various various Martian rovers revealed that Mars is quite different, has a different O12, O14 ratio. And then when they started finding achondrites, remember, if it's an achondrite, it must have come from the surface of a planet or a planetesimal. To be a complete achondrite, in other words, to be a eukaryote or a diagenate, it must have come from a planet. When they found some of these that had exactly the same relative oxygen isotope concentrations as material from Mars, they've been by the road, they thought, well, this must be from Mars, and they started looking for other aspects, and in the end, they said, well, this has got to be a great way of discriminating. So they just got all the meteorites they could get their hands on, all the different types of achondrites, and there are quite a few. Brachionites, there's winonites, there's so many of them. All the carbonaceous meteorites, what they started to do was test their relative oxygen isotope concentrations, and they found you could group them. And in the end, it became, axiomatic that what you're looking at is a varying O2, O12, O14 concentration going outwards from the sun. So that what you're looking at is it represented that, in other words, it was almost like a fingerprint, this relative oxygen isotope concentration. So if they found a rock, it's a eukaryote. They age it. Don't forget, stony meteorites are roughly all the same age. Chondrites are all roughly the same age, 4.5 billion years. Iron meteorites, here's a nice little bag of iron meteorites. Iron meteorites are roughly the same age because they have to come from the time after the planet's formed, and these are 4.2 billion years old. So if you find a meteorite and you age it, and you find it's only 1 million or 2 or 5 or 10 million years old, as opposed to billions of years old, it must have come from a planet relatively recently. If you then find it's got a relative oxygen isotope concentration that matches other brachionite meteorites or matches other lunar meteorites or other Martian, then you can assign that into that category. So you can actually get what's called an SMOW chart, which shows the distribution of those relative oxygen isotopes, those oxygen isotopes, and each group of meteorites is assigned in those. So winonites are quite special, To cut to the chase, we actually now, I think it's up to about 17 or 18 asteroids that are known to be, that have been actually pinned down. Because another thing I should say, you can take the spectrum, anything that reflects or emits light, you can take its spectrum, okay? Well, of course, asteroids have you can get a reflectance spectrum from an asteroid, and they have a characteristic waveform, okay? All the different wavelengths reflected, or what's absorbed and what's reflected. So if you do that, amazingly, it was a science teacher who found this out, who ran astronomy clubs in a place called Dereham in Norfolk. He found this out that, for example, this I've got something here somewhere. This is a famous diagenite called Tatooine. Have you ever heard of Tatooine?
Star Wars.
Star Wars, exactly. It's in Tunisia. It's a town, and that's where this meteorite fell. And it's a nice green diagenite. Okay. George Lucas is a big fan of meteorites, believe it or not, and so he chose that town, Tatooine. He used it actually for the where the bar is, where the aliens are all playing and stuff. And that was Luke Skywalker's birth village, wasn't it? He used that as the name of the planet, didn't he, for in Star Wars. But if you believe it, you do a relative reflectance spectrum of this, it's exactly the same as the reflective spectrum of Vesta. Isn't that incredible?
Okay.
And I suppose it's not really surprising, is it? Because what you're really doing, if you're spectroscopically examining the surface of, when you do it with a telescope, you're spectroscopically examining the surface of the asteroid. And it's since been found that
you could do the same thing, and using 012-014, using relative reflectance, you can actually assign groups of meteorites to various asteroids throughout the solar system, which I think is incredible. Bear in mind, when I did my degree, I've got, you know, I didn't do the astronomy stuff. I didn't do until the 1980s. And at that time, I remember, you know, asking the prof, do you think we'll ever actually definitively find meteorites from Mars, you know, or from, I mean, they're just beginning, as I say, they were just beginning to think, in 1981, they were just beginning to think there might be meteorites that arrived here from the moon. But so how about Mars or the asteroids or some of the other rocky worlds like that? Do you know, we even have, here's one, this is a meteorite that's generally considered most likely to be from Mercury. And they've worked out the mechanisms that by process by which this could happen. So when I first got into meteorites or became involved in meteorites, it was very much a niche market. And in Britain, it still is. Remember I said it's been a 20-year roller coaster, or more like a train wreck in many ways. But it's a niche market in the sense, already some of you have probably turned off and gone away to watch the Formula One. I wouldn't blame you. For a start, to actually appreciate that this lump here is anything other than just a bit of brown rock. To actually appreciate it aesthetically, you know, some of them are, you know, obviously a lot more attractive than others. I mean, you look at this pallasite. Under any circumstances, pallasites are good looking, aren't they?
That's gorgeous.
And they're incredibly rare. But you know, to make a living selling the things, you had to persuade people of that fact. And the only way you can do it is I don't sound patronising. You go and sell a meteorite that someone doesn't really know what they are. It's when you start. It's why I sell loads more face to face at you know, the Professional Astronomy Show and the International Astronomy Show and so forth, because if you can let people pick them up and talk about them and say, do you realise how old this is? You know, do you know this would have started World War III? It nearly did. It blew up over Russia's main naval base. You know, I agree with you there, John. Absolutely right. It's holding it. I mean, it's holding this thing that's been, you know, it looks like it should have a miniature Bruce Willis trying to drill a hole in the surface. Just to digress for a second, did it ever strike you as a bit strange that to try and destroy this incoming asteroid in that film, you know, Armageddon, instead of getting some highly skilled, brave, already capable of flying the space shuttle, instead of getting some astronauts and training them how to drill a hole, instead of which to get some oil rig roughnecks and train them how to fly the space shuttle. But I mean, the romance of this thing blew up over this naval base in 1947, and it was immediately assumed we now know by the Russians that it was a preemptive nuclear attack on their naval base. Now, at the time, Russia only had 2 or 3 nuclear warheads, and they were the size of a railway locomotive. They quite quickly caught up, but at that time, luckily, they didn't. Imagine, this is the thing about meteorites, imagine if that were to happen tomorrow. You know, suppose one blew up over Washington, or, you know, did I get one? Yeah, I did. This is a meteorite you've all heard. This is Chelyabinsk.
Yeah.
The great majority of the material from when that object, which I mean, I feel quite vindicated. I was the first person to suggest that Chelyabinsk was obviously a comet, not an asteroid fragment. It's obviously a lump of ice. And people's idea of comets as being like snowballs, you know, as we know, they're not. They are largely composed of water ice, but they've also got a very dense, thick regolith of material they've gathered as they go around the solar system. And when later on tonight we'll go out and look at Neowise, a lot of that material streaming off it is as you know, it's got 2 tails, isn't it, already? But what's happening is a lot, as the ice sublimates, it's also taking with it dust and bits of material. And of course, again, I'm sure a lot of you are meteor specialists. A lot of the meteor showers are actually associated with comets doing just that. can't remember which one. I mean, I've got a terrible memory as I get older, but I know Halley's Comet's got 2 associated meteor showers. Then there's Encke's Comet, Biela's Comet. So I think, this Chelyabinsk, if that had entered the atmosphere, I think the usual figure they give is 40 minutes later, it would have blown up over Moscow. And the worry is, would the Russians, for one, would they have held back, from an instant response?
Yeah.
That's why studying meteorites and studying near-Earth objects has suddenly become quite important. So we're nearly there. So that we've had common chondrites, we've had iron meteorites, we've had pallasites, and we've had achondrites, which are the ones from the surface of planetary bodies. The other thing, of course, when these things hit a planet, whether it's a comet or an asteroid or a large terminology, I'm sure you know, if it's floating about and moving towards the Earth, it's a meteoroid, okay? As it enters the atmosphere and starts to ablate and glow and leave us a trail, it's a meteor. If it explodes, it's a bolide. If it hits the ground, it's a meteorite, okay? So meteorites are material from space that actually made it through to ground surface. One of my books, I've written several books about, as Grant was kind of saying, that it's far more likely that the major comet crater-forming impacts on the planetary satellites, the planets themselves, are cometary rather than asteroidal. For the simple fact that asteroids, I mean, there are obviously some wandering about after they've been perturbed, but the great majority are in predicted areas of the solar system, the main belt, and so on and so forth. And whereas comets, there's 2 huge deposits of them, reservoirs of them, the Oort cloud, the Kuiper belt out there, and other, others that come in from God knows where on parabolic or hyperbolic orbits and the end or trajectories, and they enter the solar system, swing around the sun, and give a good show, and then disappear, never to be seen again. And of course, a classic would be Schumacher-Levy. Now, I don't know if any of you, Linda and I watched that night after night, smacking into Jupiter, and even with a 5-inch refractor, it was really easy to see the huge scarring on the surface of Jupiter. And you just think, what would that have done? I mean, it's only ice, a comet, it wouldn't do anything. But people forget that a comet, or the water, is nearly a ton per cubic metre, travelling at 30-odd thousand miles an hour. Yeah. And you've got 15, 20,000, that's a small comet, 20 or 30,000 tonnes of ice. So there's a heck of a lot of kinetic energy.
Yeah. Yeah.
So they make big holes in the ground. And my contention is most of the craters on Earth, and there's I think it's about 400 we've discovered now. And people sometimes say, do you actually collect things? I mean, I don't, but I do collect these. These are what are known as impactites. They're rocks and minerals that are formed by the impact of a large object on the Earth. This is everybody's favourite, I suppose. This is Libyan desert glass. See it? Lovely yellow colour.
Oh, yeah.
It's a glassy material, and it comes from a hotly contested region between Libya and Egypt, and it's a very, very dangerous part of the world as well. It actually was used, it was known to the ancient Egyptians. There's a famous jewel found in Tutankhamun's treasury, which is like a vulture's wing, vulture, yeah, and it's called a pectoral gem, and it's got a in its talons, it's holding a scarab. The scarab is a thing called Kepler.
Okay.
You'd like a bit of Bristol impact layer? I've got loads of it. I haven't got any here. Because I collect it. I've got Bristol impact layer. This one here is from the Scottish one in the Minch. Okay, and there's also the new one from the Isle of Skye. A lot of these things are controversial because, of course, there's only a limited amount of them. So these things here, these are these are probably the most gram for gram, the most expensive things I've got. Not very good light, is it? But you can see them. They're little they're called desert pearls, and they're some of the most. You remember my first thing I ever bought was called a tektite.
Yeah.
Well, here are some bigger tektites. These are ones from the Philippines. Yeah. Quite cute, and they're called lights.
Can you show that one
you
again?
Also get,
it was a bit quick.
Yeah. Sorry, show it again.
Can you show that one again. That's got sort of. It's almost like multiple things joined together, isn't it?
Yeah.
Yeah. That's probably. I mean, if you went back 30 years, the experts on tektite formation were two American guys, John O'Keefe and Hal Povenmire. And they're two of the geologists who trained the Apollo astronauts. And they came up with very good books that concluded that tektites were in fact from the moon. That they, the so-called Maria basins actually flood basalt plains on the moon, huge impacts that filled up with basalt. And they're trying to explain the fact that tektites have got a couple of very interesting, as you can see, this thing is oriented. It's actually what's called a shield orientation. Like an Apollo capsule, you can imagine it coming down through the atmosphere. Yeah. You also get cone orientation like that. And you also get, I didn't get one out, but I've got loads of them, spherical orientations, perfect spheres. Now, O'Keefe and Povenmire said, how is it possible that a lump, if these things were blasted off the surface of the Earth, which is what some people contend, their maximum velocity at the moment of impact, and as they went up through the atmosphere, they'd slow down, stop, and gradually accelerate back down. But as they came back down, they're not very dense, they're kind of a glassy material. As they came back down, air resistance will keep them to quite a low terminal velocity, certainly not enough to orient them or melt them or produce flight lining on them, which they have. And so they said, no, what's happened was, on the moon, there are several craters which are probably the right sort of age. These tektites are about 400,000 years old. But and we assume, most of us probably assumed at one point that the craters on the moon were all formed a long, long time ago, but they're not. A lot of serious people suggest that Tycho, as we all know, Tycho is probably one of the most recent craters on the moon, large craters, simply because its rays are overburden that have been dumped over the top of other craters and Maria basins, and some of the rays from Tycho go right around the moon completely. And Povenmire and O'Keefe suggested that Tycho was probably could easily be as young as 400,000 years. Same with Copernicus, that could be quite young. Anything that's, obviously hasn't really eroded much, hasn't. I know there's no atmosphere or climate on the moon, but the craters get eroded, of course, by impacts, subsequent impacts, and micrometeorites even. I mean, if the Apollo astronauts taught us anything, they taught us that if you go down and look at the moon surface closely, there are millimetric craters all over it, So Tycho, I reckon, was perhaps the origin. You can imagine a situation where a comet or asteroid fragment smashed into the moon, X-ray that huge crater, material was chucked. The moon's escape velocity is a lot, is a lot less than it is on Earth. I mean, otherwise the Apollo missions wouldn't work, would they? And this stuff comes chucked into space. It got captured by the Earth and formed a belt, a ring around the Earth, a bit like Saturn or Neptune, whatever. And that ring gradually decayed, and the big ones fell first, and the smaller ones. And over a period of time, hundreds of years, the material fell down and created, which is exactly what you find. These things are not found in one place. There's no crater in Indochina or the Philippines associated with these. They exist in strewn fields that go more or less around the equator. They're found in Australia, they're found in Africa, even in India, right the way across, even in America, Beagites and Georgites, Arizonites are chemically identical to these, Now, I still cling to the idea, this isn't a hideous name drop, although it is. I remember talking to Alan Bean, the Apollo 12 astronaut, once, and about this, and he said that one of the rocks they brought back from the Apollo 12 mission, which is called A12014, you can look it up, was actually a tektite. So you either assume that somehow tektites and other ones were found as well. I mean, you think about what's the chances? They randomly 6 landing sites with 700 kilos, is it, or 700 pounds of rocks they brought back. What's the chances that quite a few of those contain tektite? It's much more likely that tektites formed on the moon. So that's these impactites. So you've got tektites, you've got Libyan glass. You can't get this stuff anymore. It's called Moldavite. Can you see it's green?
Yeah.
Moldavite is quite exciting, really. It's named after the Moldau River in the Czech Republic, and an impact a couple of million years ago in Germany. Twin impacts created 2 craters. Stenheim crater, the Reefs crater is the bigger one, and it's known that this Moldavite was formed when silicaceous material was fused into this green glassy stuff. It splashed across into what's now the Czech Republic, and it's found in these sort of deposits, sandy and clay deposits, Moldavia. I would just say this: that the trouble is, I'm assuming you're beginning to realise that, despite what you might think or what people might assume, although it's 300 tons minimum of the stuff lands on Earth, hardly any of it gets found. Yeah. And cheers, Steve. When you look at this, I sell these. This is not a plug. Of course, Grant was kind enough to say that I could mention the name Space Rocks UK, or if you type Google buy a meteorite UK, you'll find, or my name, it'll come up. But I sell these for £15 a go. And people say, how can you? It's really quite rare. Genuine Moldavite is quite rare, and it is highly prized as, unfortunately, the gemstone. Same as this. I had a Libyan guy. I still have his address. He's been a bit quiet recently, and he actually goes once or every now and again to this region and brings this stuff back. Now, human nature being what it is, I have to confess, I used to get slightly irritated at some of the rock and gem shows. I don't do rock and gem shows anymore because it started off being fossils, minerals. There was myself and perhaps maybe one other person who might have a few meteorites. And then you start getting little angels carved out of crystal, and little fairies and wands. And then you get these people wandering about with tektites, and they'll be going, what are you doing? Oh, I'm just clearing my chakras. Yeah, okay, whatever. You start to hear these ridiculous properties being claimed for these meteorites. And it's because, let's face it, these crystals, Reiki healers, crystal therapists, I mean, they come up with the most. I used to say to them, if these things work, why are you such a mess yourself? But to cut a long story short, they were making outrageous claims for things like Moldavite. They'd cure your HIV or cancer or anything, They'd unblock your chakras, and what they wouldn't do. So the result is you've got several different groups trying to. You've got the jewelry makers trying to get hold of it. You've got meteoricists and geologists trying to get hold of it, their collections, and then you've got the crystal therapists and the airy fairy types. I hope I'm not stepping on anybody's belief system, but to me it's a bit like flower therapy. I'd want to see some decent research into it, but So the trouble is, there's only a limited amount of it. You can see this is going. The price of the stuff went through the roof. If you get a decent sized, suppose you could get, suppose you had a piece of Moldavite that big, right? Okay, a genuine piece of Moldavite from the Czech Republic, Bezinice in the Czech Republic, that would be worth £600. Whereas in the old days, you could pick it up for nothing because nobody wanted it.
Yeah.
which leads me on the last thing I probably want to say about this, which is a caveat emptor. I don't sell on eBay. The reason I don't is because it's quite hard to get sufficient material. I mean, I've got literally tons of this stuff. Okay, small, medium. These are lovely little individual meteorites here from the Sahara. I mean, I've got quite a nice legacy stock. But if I were to put those on eBay, for 10p each or something, I'd quickly run out. A classic is these. I have, as Grant knows, because he's kind enough to discuss these things with me. These here are fragments of the Arlene meteorite. Remember that big one I showed you from Russia? And I have several customers that for jewellery making or for those geology shops and people who sell the stuff who have a regular order for this. And it's getting harder and harder and harder and harder to obtain. Yeah. So I don't, so the first thing, the reason I don't put things on eBay is I once you sold it, I seriously doubt that I'd be able to resource a lot of the material. It's just too rare. The other reason is a fair percentage of what's sold on eBay is fake. It's just not genuine. How would you know, that was a Martian meteorite? I know because I got it from a guy called Stefan in Germany, who owns half a dozen main masses, and he and I have worked together for a long, long time, for 20 odd years. He used to have a partner, but he's on his own now selling the material. He's a good friend and 100% trustworthy. He's not in it, but he and I met through the International Meteorite Collectors Association, the IMCA, and we were both charter members of that. But this has been tested, it's in the catalogue, with its complete chemical analysis. And so I know it's a Martian, I know that was a lunar, I know so on and so forth. If you bought that from somebody you've never heard of, that's a good question, John. If you bought that from somebody you'd never heard of, it could be anything. I would know any chondrite. You get some of the really impressive ones like carbonaceous chondrites like this. Can you see the chondrules in that? Yep. The little balls. Yeah. These are the famous ones. These are from various asteroids. They have a sooty matrix which contains over 100 amino acids.
Wow.
You've got 23 amino acids. It's got over 100, and people have claimed they've found in those. As we've got some really ancient material, pre-solar grains, calcium aluminiums that are older than the solar system. They come from outside the solar system before the formation of our planetary bodies. So I would know just by picking them up, by looking at the heft of it. After a while, you do get pretty good at. But I wouldn't know whether that was a lunar or Martian. I could probably tell it if it was a whole lump. You could tell it was a chondrite where it might perhaps have a fusion crust. But don't forget, chondrites don't have any metal in them, so you can't use the magnet test on them or the nickel test. That's another good way to test for things a meteorite or not. Get a boost nickel tester, because meteorites all have nickel in them. But these don't. So I wouldn't know. The only way I know that's a genuine Martian meteorite, and it genuinely is NWA 12269, and it's a Sherga type found in the Northwest Sahara in 2008, blah blah blah. It's because I bought it from a bloke who owns the main mass. Mm. So caveat emptor, and even worse, Moldavite is green. End of story. It's always that colour. Okay, China, and I'm not being I'm not being critical of any race or a particular group, but the Chinese, unfortunately, they've kind of trying to they are taking over the meteorite and mineral and fossil world. 90% of the fossils on eBay have come from China. It's a huge country, and people have. There's some really amazing. Some of the first fossil small dinosaurs with feathers come from China. Mm-hmm. Some incredible. But my favourite meteorite is a palisite called Semshan. That's it there. A lovely green, translucent crystal. Yeah. It's beautiful. Comes from Russia. various Chinese consortia have bought up virtually 80% of what's left of that. And the same with Moldavite, even tektites. Grant will know of a meteorite called Mona Illustra from Sweden. Yeah, they bought most of that. And what they're doing, they cut them, they polish them, and then they flood the market to capture a market. You know, and they're putting a lot of people, the smaller dealers and things, out of business. You can't compete. You go to, when I first used to buy these chondrites, I would pay. It sounds like I paid what they asked me, which was $70 a kilo for the rubble and $100 a kilo for bigger pieces. That price has gone up into $300-400 a kilo now. So that's a factor of two things. One, because the stuff is running out, and B, because having captured the market, you know, it's very hard for anybody else to get a toehold. You want to try and buy this stuff, it's very difficult to do so. You know, I would say if two Englishmen were shipwrecked and ended up on a desert island with a chair, then they'd soon start an antiques trade. That's kind of how it's got in the meteorite world now. That what's happening, people are, you know, cycling the things. A guy in Germany will get, like this Stefan will get a nice lunar meteorite, or he owns the main masses, almost certainly Mercury meteorite, and he'll swap a bit of that to somebody who's got a really nice brackionite, or somebody else who's got, you know, another rare type, you know, an L3 or something. And what's happening is that we're all waiting now. It's a dreadful thing. You're waiting to get what's called legacy stock, where people with old collections pass away and their material becomes available. Yeah. So some sort of legendary meteorites, like some silicated ions like Miles and stuff. There's a lovely pallasite from Australia. And then there's the famous Wolf Creek, seeing all your boxes and packets, they look, what? No, they're not unstable. They're
unlabelled. So saying, do you store them labelled, or do you just know what's in what by looking?
No, they're all labelled. I'll just take them out so you can see them. Yeah. Oh, by the way, you've ever watched a James Bond film? I forget which one it is. Do you remember they go for he has to drop down out of a helicopter down a well? Do you remember that? And at the bottom of the well, there's a little cave, flooded cave. And it's called the Tears of Allah. Yeah, that's what these are. That's what these desert pearls are.
Oh, okay.
Tears yeah, and these are very valuable. They're an impact type from a little crater. I can't remember what it's called now. The deserted region or something, you know, in Saudi Arabia. Yeah, everything I sell is not backwards. For some reason, the cameras do things backwards. Everything I sell has got a full provenance on it. Everything is sold with an A4 printed sheet and certificate. And somebody asked a question about the IMCA. Back in the day, 20 years ago, to get into the IMCA, say for example, the Royal Astronomical Society, right? To get to be a fellow of that, in the old day, you had to be promoted by two sort of people who were already in it. You had to have a reason for being in it, and you had to prove that you were genuinely, you didn't just want it as so you could put the letters FRAS after your name or whatever. That's how it was with the IMCA. But they've always said you only have to be nominated by one other existing member. And what was happening was that, let me just say, some groups that are less than dependable were, to give their material credibility, were nominating all their friends. So it's a good question. I would still say this: if you buy something from somebody who's a member of the IMCA, and if they are, they'll have their own charter number. Mine's 1898, which is quite an early number. It doesn't sound it, but it is. It's quite an early number. If you go on the website, on the IMCA website, you can actually find out the biographical details. So if it will say trades in Peckham Market out the back of a three-wheeler, probably best to avoid that. But if it says, the guy has been trading for 20 years, a famous collector, associates with so-and-so and so, and owns the main mass. So it's still better than an anonymous seller,
The other thing is most of the Chinese dealers on eBay, if you look, don't use their real names. And you might say, well, but they use noms de plume, you know, so really you're not really dealing with an individual dealer at all or a seller. You're dealing with a consortium of business people. So, one last thing. These are absolutely cool. These are diamonds, and they're called carbonados. They're black diamonds. But these particular ones are associated with impact strewn fields on either side of the Atlantic. So they were produced, or they were the result of an impact before the Atlantic basin opened up. So what's really exciting about it is, you know, they know they're extraterrestrial because the allotrope of carbon in them is Buckminster fullerene. Okay, they've got buckyballs in them, although they are proper diamond. And I got mine from Hatton Garden. They are used for jewellery, but they're mostly used commercially for drill bits and stuff. But it's a very exciting, you know, possibility that these were formed by the impact of comets or asteroids on the gas giants, or some of the gas giants. You know, as you probably know, if you compress hydrogen, carbon dioxide or methane, we'll get crystalline carbon, diamond. You can actually make diamond. It's more expensive to do than the value of the diamond you get. But so, you know, in other words, the more you know about meteorites, the more exciting they are, the more interesting. And the answer to the question, all my meteorites, I have got a huge, I mean, it doesn't sound cocky, but it's true. I've got by far and away the largest inventory of any dealer in Britain now or in the past. I've got loads more than Rob ever had. He used to go for just really classy, expensive, you know, like lumps of Barwell like that, or, you know, some of the really really rare things, and he'd have, whereas I've got, you know, sort of, I've got Campo del Chelos this big. I do sell them up to the size of a dog, really, occasionally, but he'd have vast things, you know. So he would sell things in the tens of thousands of pounds. I always thought it was a bit of a, you know, bit pointless exercise because you're only going to sell 4 or 5 a year. Gentlemen, you're going to think I'm flanneling you now, but part of my reason for doing this was always because I've been so excited by meteorites since I was a kid, as you heard, since I was 6. I proselytise from, you know what I mean? I'm like I want to promote them. I feel sorry for them because they're so exciting and so incredible. Somebody said earlier, it's actually to think that here, you look at this lunar meteorite here. You can see it?
Yeah, yeah.
And you look at a breccia here, you've got lumps of anorthosite, you know, which is a feldspar, so it's a feldspathic breccia, and you've got bits of basalt there from the, and how cool is that? You know, you know, my generation, and I guess everybody, even young Grant there, you know, we're not going to go to the moon, but I can actually hold a chunk of the moon. And that might seem a lot of money. I think it's about 120 pounds or something like that. That might seem a lot of money. It's illegal to own material that came back from the Apollo missions. It's the only way you'll get them is an authentic lunar meteorite. But when you look at it through a binocular microscope, it's fantastic. And this is not an advert, it's just a statement of fact. In some ways, it's the wrong time to get involved in collecting meteorites because some types are worked out. They're just like that. I'm sure a lot of you have heard of a wonderful carbonaceous meteorite called Allende. It's got beautiful big chondrules. It's got a lovely sooty matrix full of amino acids, you know. Fell in, naturally enough, in Mexico, so it's called Allende, arriba. And there's another one called Murchison, which is, you know, one of the first ones that was found. It's strongly suggested that it's actually got nucleotides in it, not just amino acids, but actual nucleotides, you know, the building blocks of DNA, and so on and so forth. You can't get them anymore. You know, what little there was available has been sold, and again, you're now waiting for people to, you know, to move it on or sell it or get bored. But it's very rare for people to get into collecting meteorites. It's very rare that they give up. Some people, you know, want a type set, one of every type, the biggest piece of each of the different achondrites, you know, the anomalous chondrites, each of the different types of pallasite and so on. Other people just want one big one of each type. I've got a new lady customer, she's a teacher from Essex,
and she happened to buy my book, as a matter of fact. And Space Rocks. If anybody wants a copy of this, you get in touch with me. It's supposed to be, it costs a lot of money to have a book printed these days. Every picture in it, as you can see, is colour, full colour, okay? It tells you everything I've been saying, where the meteorites, how to recognise what's a meteorite, what isn't. You know, it's got some meteorongs there, things that look like meteorites, but they're not. Where you can see meteorites, various collections, and so on and so on and so forth. Then if you want one of these, if you get in touch with me, I'll knock a $5 off and sign it for you. Anyway, that's how she got into it. And she bought 4 or 5 meteorites now. She's bought a lunar meteorite that big, a Martian meteorite that big, a pallasite that big, much bigger than this one I showed you. One of the biggest oriented stone meteorites I ever had, it was with a mass of 2 kilos. Beautiful. It's got regoliths on it and regmaglyphs on it and everything. Flight lines, beautiful. And she bought a big Sikhote-Alin, not quite as big as that, not quite as big as this. But every month she just treated stuff. I think she kind of reached the end now. You know, I think she kind of said, "Oh, she wants a big tektite." She's bought one of those Muang Nong, those stratified tektites. They're quite rare. She bought one of those. That's another idea. But
what's the value of the one you just held up, David? That Sikhote-Alin. What's something like that go for?
That one there. Again, deep breath. It's going to sound like a lot of money. But when you think what it is, and you think how are these this size, I bet there aren't, in private hands, I bet there are not more than 2 or 3 of these in Britain. Wow. This size, 1,600.
Wow.
Gosh.
And it seems, but what can you get?
I think for what it is, what it means.
Yeah.
It's.
You look at it, it's oriented to some extent. It's shield oriented on that side. It's coming into the atmosphere. This particular meteorite exploded several times as it came to the atmosphere and changed direction. And the bits that broke off right at the top were still going fast enough to actually orient or to you get flight lining and stuff. As it got further and further down and subsequently blew up, you get what's called shrapnel. Okay, so you've got oriented material, then you've got shrapnel from the 4 or 5 explosions. And as you say, you can see that in it. If you look at this one, you can actually see on the surface, you can see the flight lining on it. You can see how it's, as it's coming in the atmosphere, how it's, probably doesn't really show on here, but in your hand, you can see how the iron has gone flowing over the edge as it's come down, as it melted. It's just a wonderful thing. It's a historical document, really. When I watch these programs on the telly, like Antique Roadshow and that, and they have all this sort of tat, don't they? Like a Clarice Cliff or something. I shouldn't say that because I collect old glasses, you know, drinking glasses. I've got some, you know, going back to the 18th century and stuff, just because they're, you know, they're cute. But you get a bit, and on there, suddenly they'll have something like a Neolithic axe head, yeah, hand axe, or they'll have a they had a lacrimal bottle or a Roman, and this thing was like 2nd century AD, a little glass bottle from, and they said, oh yeah, it's worth between 80 and 120 pounds. I thought, it's ridiculous. Some crummy pot, like Clarice Cliff, or, you know, one of those, you know, all those troika vases and things, which I remember seeing, you know, when I was a kid on holiday, you know, for £4 in the gift shops. Those things go for hundreds and hundreds of pounds. It's because, you know, it's a different kind of person buying those. They're buying them for investment, and they're buying them to deprive other people of them. Really, that's why you do it. Yeah. These things here, I think, if you supposing you suddenly had a bequest, last thing I will shut up then. One of you is going to ask, or is dying to ask, are these things an investment? Yeah.
Dave, are these things an investment?
The simple answer is I've never ever sold one of these to anybody and said to them, you know, and said they're a good thing to buy, they're a great investment, but I'll tell you what they are. They certainly are. Like I said to you before, if you had some of the original material back in the 70s, 80s, as it became available, things like Tagish Lake, Murchison, Gibeon, you know, the famous meteorites, some of those carbonaceous, other carbonate, you know, you could have bought them for nothing. I know a guy who's got an Allende the size of a football. Okay, he's got I've got a customer, right? He lives down in Brighton, and he's been buying from me for 20 years. And all he buys, and he buys them because he likes them. Okay. He buys things because he likes them on an aesthetic level. He's got the most astonishing collection. He's got a Carcharodon megalodon jaw matrix. He had that made for him. He's got a full set of the teeth, you know, megalodon, giant shark's teeth. He's got a Spitfire engine in it, made into a coffee table. He's got, any of you know about military, this is unbelievable. He's got King Tiger tank shells. You know, there's only 5 in Great Britain. He's got 2 of them. Anything rare, unusual, anything that tells him a story. He's only a very ordinary bloke. He owns an industrial cleaning company. He started buying things. He's got lumps of, you know, that lovely palasite. He's got lumps of semshan that big that he bought from me, and he paid perhaps £200. That would be worth. I could easily sell that now for 5,000.
Wow.
That's it. That's in 15 years.
Yeah.
He's been very wise. He's bought quality material. I refuse to sell things unless there's something extraordinarily rare and people demand they want to have a piece for their collection. I won't sell things that are unstable. I won't sell things that are going to go rotten or rusty. You know, as long as you don't take it in the bath with you, this beautiful. If I get the light behind that, you can see why I rave on about palasites.
Oh, yeah.
Translucent, see? Isn't that beautiful?
Yeah.
The olivine crystals. They're actually green in real life, but there we are. These things have proven to be very good investments, and these are going up all the time. I mean, I think, as I said to you, that's £300. That's quite a big slice. There was a time I could have bought that for £60. I probably paid £240 for it. No, it doesn't sound like good business, but the vast majority of what I sell are the least expensive end. Mm. And anyway, I'll tell you the best thing this bloke's got that I got from, you know, I used to sell space flown memorabilia and stuff. Yeah. A guy got in touch with me and his wife from Germany. He lived in Peenemünde, and he said they'd found a crashed V2. Did I want to buy it? I said, well, no, but I'll buy some bits of it. So I started getting the injectors, these big injectors and things they're like flower pots with little nozzles in, and guidance stuff, and graphite fins from it and things. And cut long story short, an American guy, not so famous, called Peter Merlin. This is how it works in meteorite dealing too. It's who you know, friend of a friend of a friend, you know, and you get a chance thing. This Peter Merlin is the only guy who's allowed to go looking on the Edwards Air Force Base range where he's tested with the American. Cut long story short, he started bringing me swapping for bits of V2 that cost me nothing, like threepence. He was swapping them for bits of X-15 that's flown by Neil Armstrong, bits of Blackbird SR-71. You know, I actually had the skinning off the tail fin of an SR-71 Blackbird made of titanium. I mean, the value just as a piece of titanium was in the thousands. Well, one day he sent me in to swap some little bit of a V2, a gyroscope bit. He sent me a Peter head cover from a famous Blackbird, one that broke the all-time record for flying across America to Britain and back again. And it's the Peter head cover with a long streamer saying removed before flight, full authenticity, and that sort of stuff. This guy bought this from me, this guy down in Bryant. I framed it in a big oak frame. It's big. I mean, it's over a metre long. It looks beautiful. I framed it on a beautiful glazed oak frame. He bought it from me for £300. He's turned down £25,000 for it last week.
Whoa.
So things, I can't afford to hang on to things. As soon as I get them, I sell them on.
Yeah.
So are they a good investment? If I'm really honest with you, if you buy the quality material, yes, it is. If you bought, I sell these by the bag, by the way. They're 25 quid for a bag, and that's, you see how many are in there? Yeah. Full of them.
Yeah.
You could, at that price, you can afford to give it to your friends, or people you really don't like. But I mean, they wouldn't be an investment. But anything else would be. I mean, these rhyzolites, the iron meteorites, the pallasites, anything quality is an investment. Somebody was talking before about Bristol impact. The Bristol impact layer is astonishing. There's a huge crater in Canada, okay, Manicouagan, and the material from that Manicouagan impact, which is very ancient, landed, because in those days Bristol and Canada were 2 foot apart, sort of thing, landed there as a layer of little these tektites, like these micro tektites, but even smaller, and the little green balls, and you've got this lovely reddish, fine reddish clay, sandstony clay, with these little green balls in it. They look like the bubbles in a mint aero. And this deposit was found quite by chance when they were building a leisure centre outside Bristol. And when I first got hold of this stuff, I mean, I wanted something for my own collection. Also, it's absolutely beautiful when you look at it under a lens. And it's very rare. Impact material in Britain, as you know, is very rare. You've got the Sky stuff, you've got the Stack Fadder stuff from the Minches, and you've got the Bristol impact layer. That's it, okay? There might be some tektites from Morton on the Naze as well, in their sort of red crag beds. But I would buy lumps of it like this, you know, for £5. And of course, I didn't think about, and I was cutting it to slices and selling it very cheap, or putting it in boxes, display boxes for colleges and stuff. And I quite quickly ran out the 2 big lumps I had. And I got in touch with the original guy and said, well, can I have any more? I said, well, the hole, you know, they've built the leisure centre, and the excavation is now a lake. And it's at the bottom of the lake. And so it was a one-off opportunity. And luckily, I've quite by chance, legacy thing, I came across a guy who had some big lumps, and I bought those. So I actually still got some. And now, I mean, I've got some, I didn't bother getting it out, but a slice like that of the Bristol impact layer is worth £300, purely because of rarity value and fascination. So yeah, they are an investment, but if you are going to invest in them, my first thing would be like anything else that you're going to collect, but don't buy it as an investment, buy it because you like it, because it's exciting, and because you're holding something. Kids get really turned on. I have to say, I used to go around schools a lot more than I do now. I mean, I was a teacher for 35 years, but I stopped teaching in 2000 for all the usual reasons. And I've done this full time. That's why I say I'm Britain's only full-time meteorologist. It's what I do for a living. You know, even though chemically, or you know, technically I'm retired, I'm a pensioner. I need the money from this, as, you know, to support my claret habit. No, I mean, I do because I love it. How else would I have that? But I remember going into school actually it's the school where that science teacher did the reflective index, you know, spectroscopic reflective index thing. Anyway, they asked me to go in then and work with some very, very intractable teenagers, 16-year-olds, who weren't really going to pass any exams. All they wanted to do was go in the army. Good luck. Good, fair enough. I bet they were great squaddies. But they'd actually been very threatening to some of the teachers, quite physically quite big. And I've always had a reputation in teachers being good with kids, you know, look like that sort of kids. Is Grant's son there? I've got to be careful what I say here. Anyway, this kid was causing a bit of trouble at class. He just come in, come in. He was about 6'4", and he played rugby for Norfolk. He was only 16. I said, hold your hands out, and put this in it. I said, what you're holding, or one light, it's not this particular one. So what you're holding is 4.2 billion years old. It's the core of a planet that was disrupted and shattered by an unimaginable impact. It's been traveling through space for millennia, and it arrived in this particular case in Argentina several thousand years ago. And the natives saw it land, and that area is still called to this day Campo del Cielo, the field of the heavens. And he looked at me and said, now you knew that, and I couldn't care less, so why did you tell me? I mean, I'm not sure that was an authentic, original thought. I just laughed so much, and one of his little mates Right. Grant's son knows, but one of his little mates said, "Can you eat it? Can you drink it? Can you put your hand up its jumper?" No. What good is it? So not every, but 5% of the people it shows. I tell you what I love doing. I'll shut up now. Honest. One of the events I most love doing, I'm so sad it had to be cancelled this year because of COVID, is the open day at the Cambridge Institute of Astronomy. Some of you bumped in. It's just a wonderful event.
Right. And
Dr. Crawford's just the most wonderful person. She really is. I mean, she's done so much for astronomy.
Yeah.
And her husband, you know. And it's just such an honour being asked to do it. I think I'm the only person who's allowed to go to and flog stuff at that. It's only because she collects meteorites, I think. Anyway, this is going to sound terribly elitist, but of course you've got people from all over the planet with, you know, and to go there, you know, to study or to lecture or to research or to do a PhD, because that's where all the astronomy PhDs are done, and their kids there. And of course, you know, every other year, I get invited to do their pantomime as well. I usually have a star role as Dr. Spock or something, you know, and I have to do a lecture and talk. But what's amazing about the open day there is all the children who come, from hundreds of them, thousands, literally thousands. Some of you have been there. You've been to other events like the BAA things. But this is just amazing. And you know, unlike the kid in Dereham, they stand and they look at these things and they go, you know, how did that happen? And what's this? And how do we know? And can you be sure? And they ask all the right questions, and it's just a pleasure and a joy, you know. And that's the satisfaction I get from doing it. And as several of you have said, you know, there's a girl, and she's had some very grave disappointments. But I first met her at one of the Rock and Gem shows, her and her mum and her sister, and she was about 14, I think, and she got really interested in looking at the meteor, and she was obviously, she had that imagination, could make a conceptual link. And she went on to do a degree in planetary astronomy. And and she did it in, I want to say Swansea or Cardiff, but whichever university it was. The funding for the course was withdrawn when she was halfway through it. And so she had to finish it in other ways. And at the end of all that, I mean, she's always had a slightly delicate, you know, psyche as well. But at the end of it, you know, she found that she was getting, because it's a science degree, she was getting job offers from insurance companies and things like that. You guys all know, particularly you, Grant, 90% of astronomy PhDs end up selling telescopes for a living. You know.
There's plenty of
sorry?
There's a lot of people out there that, yeah.
Oh, yeah. I mean, you look at Greenwich, they've folded up, you know. A lot of them are, you know. But the point I'm making is, I think the future of any society is education and knowledge. You know, we've seen so much ignorance, haven't we, over the last 3 or 4 months, ignorance being used as an excuse for aberrant behaviour. That's why, you know, that's why I carry on doing these things, and it's my hope and ambition that, whereas not everybody can, you know, go out and take 5 hours film of a dark area of the sky and then process it, and then you've got a nebula or a galaxy. So not everybody can do that, and you need to spend a lot of money. But you can, you know, you can actually hold a piece of outer space. You can hold a piece of the moon. I suppose it's to me, it's a physical link with, you know, what all of us find so marvelous. You know, what was it now? In an hour or so, we'll be able to see this comet. There are two sorts of people: the people who stand and look and go, "Oh yeah," you know. Then we'll look at it and think how far it's travelled. Are these, you know, Wickramasinghe and all that? Are these the vectors of did COVID-19, did that arrive on a comet tail? No. I'm a great believer in panspermia. I really am, you know, because it's beyond. To me, it's beyond. And so, to finish, gentlemen, thank you so much. Meteoritics to me is a genuine branch of astronomy. It helps us actually understand planetary formation, stellar, you know, obviously stellar evolution too, you know, from pop 321 stars, formation of heavy elements. you know, and I just find it's a really exciting time to be involved. On the one hand, a lot of the, you know, the famous meteorites have exploded. But on the other hand, I've now got lumps of lunar meteorite, little ones like this, which I can afford to sell for 50 quid. And these things weigh 1/3 of a gram. When I started selling lunar meteorite, I've got hundreds of them. A new find. When I first started selling lunar meteorites, it was $1,000 or $1,200 a gram.
Oh, gosh.
So it's a good time because there's more stuff being found, more being identified. We've got new ways of recognising stuff. But on the other hand, it is a finite resource. If you wanted to get some, I'm not saying get it from me. I mean, you know, but it'd be a good time to do it because they are getting rarer and rarer. Our 20-year gold rush is more or less finished. Okay. And if you were to start trying to buy a good representative collection of meteorites like my new customer Carol, in 5 years' time, I predict it would cost you a lot more money. What's that question just popped up there?
It's just a comment actually from one of my moderation team, Mark at Beaufort. He said, David, that's been a wonderful presentation. He has learnt so much, and indeed he's right. Indeed he's right.
I just hope you don't retire anytime soon, David, because your enthusiasm.
I'm never going to. I won't retire. I've decided not to.
Massively contagious. It's so good to hear you talk about it. It really is a pleasure. Thank you.
You've been very kind, all of you. Yeah.
Indeed.
And as I say,
indeed.
if any of you really, isn't that kind? As I say, if any of you want to, just mention this talk, and I'll give you a serious discount.
Well, that's very good of you. As Grant says, David, we certainly hope you don't retire anytime soon, and obviously we look forward to being able to see you in person again. I was looking at the Kelling Heath campsite.
I'm booked in for that.
Yeah. So fingers crossed. That looks like it's going to go ahead. Their facilities are open, so we never know.
I'm not sure about the PAS. They are still talking about that, aren't they?
Yeah. So hopefully we get to see you in person in the not too distant future.
Yeah, well,
that would be great.
More importantly, you'd be able to pick up the meteorites and play with them.
Absolutely. Yeah, absolutely.
Okay. Thanks so much, guys.
Yeah. Thank you very much indeed. I think you are well overdue a nice cup of tea or something medicinal. Perhaps that claret. Yeah.
No, I've got to say so. I want to get some. I've taken a lot of images of this comet, and I've been lucky enough to get some of the first pictures just using a 300 prime and a 1.4 converter. You know, I've just got such lovely skies here, and it's been quite widely published, but some real good ones. I want to get a photograph of its ion tail tonight. You know, it's got two tails.
Yep.
Dust tail and ion tail. I want to try and get that, and that's, you know, I haven't got a motor drive, unfortunately, so it's going to be a question of stacking images, I think.
Okay.
Short exposure, you know, and then stack about 500 pictures and see what we can get.
Very good.
Good luck, gents, if you guys are looking for it tonight.
Yeah, it's certainly my intention. It looks like it's going to be clear over here, so I should be giving that a go. I promise.
David, okay. I've as we was going along there, I came up with a whole host of questions for you, and I'm just very conscious that it's quite late now. So rather than firing at you now, I wonder if at some point in the future we can have you back to talk about some meteorites.
Oh, anytime you like. You know, I'm free as well, so I'm good value.
We could talk all night. So
I'd love to. I've got nothing to do, but you guys have. Anyway, I'm going to go over and watch Lewis Hamilton win the Grand Prix.
Spoiler alert!
Spoiler alert!
Thank you very much, David.
Possibly. Okay. Well, we'll definitely go and watch England lose the flipping Test match. Bring back Chris Broad. Right. Great. Okay. Thanks ever so much.
Thank you very much.
Just a real pleasure. You've been wonderful. Thank you.
Just before we go, I was just going to announce who was on for next week. Just very quickly, which is we've got Gary Poyner coming along to talk about variable stars. So that's next week talk, but the details will be added in the next day or two. But otherwise, thank you very much.
I think it's actually me booked in.
Oh, sorry, no, you're doing a midweek one. Sorry, Daz.
I am. No, that's okay. That's okay. Yes, if anybody's interested, I'm doing a midweek one on Wednesday on Sequence Generator Pro. So you'll be very welcome to come along to that. I really do think we ought to get Dave Harvey to do some sort of session.
Okay. guitar lessons.
Absolutely. Righto, guys. Thank you all very much indeed.
See you in the comments. Thanks
Yeah.
very much, David. Cheerio, everybody.
See you all soon. Cheers.